Once again, you are welcome to another lesson, actually the second one of electrostatics. This is A-level physics paper 2 for the case of the Ugandan education system. And in our first lesson, we were looking at charges, their signs, and then the force between them, connecting to what you had studied in the lower levels, where you knew that if you have two charges which are like, if you bring them close, they repel each other. And if you have those ones which are opposite, which are unlike, maybe a positive and a negative, those ones will attract each other. That's very good to know that actually unlike charges attract each other. Then the like charges, they try to repel each other. But at our level, we want to go another step of knowing, yes, the two charges are attracting or repelling by what quantity. We want to treat it mathematically. How do we do that? Some scientists helped us to do that, and one of them is called Coloumb, and therefore he gave us Coulomb's law of electrostatics. We want to see the treatment of this law, to get the law and use it in calculating the magnitude of force between any two charges. And what did Coloumb say? He said that if I have two charges at a separation of a distance, then the force between them is proportional to the magnitude of those two charges. But it has a limiting factor, that is inversely proportional to the square of the distance between them. That is to say, if you have two charges, a charge Q1 and another one Q2, these are your point charges. They are at a separation of a distance, let's call it I. We say that the force between them, call it F, is proportional to the magnitude of the charges and inversely proportional to the square of their distance of separation. That is according to Coloumb. We can go ahead on the mathematics. When you have this, you can move it and put a constant. Therefore, force equals, put a constant, let's call it K. Q1, Q2 over R squared. This constant depends on the medium in which the charges are situated. And when experiments were performed, this K was found out to be equal to 1 over 4 pi epsilon. We all know pi. Where this epsilon is called the permittivity. Permittivity. How permissive is that medium? Does it oppose or it supports? So this is called the permittivity of the medium. And since we shall be doing many of our experiments and many real things are done in air, then we are going to consider a lot of, much of our time, we shall consider our environment as air. So therefore this, we shall call it epsilon naught, which is actually permittivity of air. So this is the permittivity of air. And this permittivity of air, actually it has a value of 8.85 exponent negative 12 farads per meter. So when you get this, actually I want you to get it. Get this and substitute it here in this. You know the value of pi. Just use the pi on the calculator. Or you use 22 over 7. You will find out that this k is actually 9 exponent 9. When you get this substituted here, you'll be able to find out that the k is equal to 9 exponent 9. So, getting my k and I substitute it there, what do I get? I get that force equals 9 exponent 9. Then Q1, Q2 out of R squared. That is a very important formula that we are going to be using for more of our calculations. Since we are beginning electrostatics, we have got the force, then plus the electric field intensity and the electric potential and others. So we shall be always quoting this and we shall be using it. Where does it come from? From Coulomb's law of electrostatics, which states that the force between any 2-point charges situated near each other is directly proportional to the magnitudes of the charges and inversely proportional to the square of the separation between the two. When we talk about the magnitude of charge, even if it was negative, just bring that charge. If it was negative 7, just press 7, because we are saying magnitude. We don't consider a negative sign. We can write it down. We can write it down. Let's write it down. Yes, this is what we end up with according to Coulomb's. The law, we have stated it here, can always follow. We are having our two charges, Q1 and Q2, at a separation R. The force becomes the product of the magnitude of the charges, then inversely proportional to the square of the separation. We put a K and remove the proportionality symbol. We get this, but K is equal to that which was got experimentally. That is where this epsilon is the permittivity of the medium. But we are saying, in case when we are doing our things in air, our medium will be air, and we shall consider the permittivity of air, which is 8.85 exponent negative 12 farads per meter, which when we substitute in this, we substitute here, we get something close to 9 exponent 9, and therefore when we substitute our k in our equation there, we shall have force equal to 9 exponent 9 Q1 Q2 out of R squared. We shall do examples. Examples. 1. Find the force between 2-point charges of plus 4 microcoulombs and minus 3 microcoulombs. Press 10 centimeters apart. We can sketch. Maybe this is plus 4. This is minus 3. These charges are very small in this exponent negative 6. And we are told this distance is 10 centimeters. So what is the force between the two? We follow this one. We say that force equals 9 exponent 9 Q1 Q2 out of R squared. So what is the force? Force equals 9 exponent 9. This one, we need the standard unit, the SI unit. So therefore, this mu is the exponent negative 6. You can actually check on your calculator. The mu will give you the exponent of a negative 6. So this is 4 exponent negative 6 of a Coulomb. And then this one 3. We don't take the negative, we take the magnitude, which is 3 exponent negative 6. Then the distance of separation is 10 centimeters. You have to change it to meter. Remember, the SI unit of distance is a meter. So 10 centimeters, you can just say 10 exponent negative 2. Or somebody can just say 0.1. But then this one is squared. That one is squared. So which force do you get when you press on your calculator? Which force do you get? Me, I am getting 10.8. And the SI unit of force, never forget, that is a Newton. So I get 10.8 Newton as the force between those two charges. If I would ask, is this force attractive or repulsive? You could answer it only in your mind, don't even tell a neighbor. Is this force attractive or repulsive? Why? We can do another one. Let's do another one. We have 2 point charges, -3 microcoulombs and -5, which are placed 8 centimeters apart in air. Calculate the force between them. If I would also sketch, this is 1 -3 microcoulombs, and this is -1.5 microcoulombs. And the separation is 8 centimeters, which I can actually call 0.08 meters. We know why. So what's the force? We said that force equals 9 exponent 9 Q1 Q2 out of the separation squared. Therefore, our force will be 9 exponent 9, then 3 exponent -6. We already know that. 1.5 exponent -6. Then the separation is 0.08 squared. So when we reach here, the rest is the calculator work, and this is equal to, you can press your calculator. When I press mine, I get 6.3281. And the SI unit of force is a Newton. So these are the Newtons that we have. This is very easy, very simple. Just take it up. Let's have one more. Let's have one more, so that it can be slightly different and we see how we handle. We have 2 positive point charges at a distance of 0.1 meter, and these 2 repel each other with a force. Now we are given the force of 18 Newton. If the sum of the charges is 9, calculate the magnitude of each charge. So we don't hesitate, we begin. Force equals 9 exponent 9. Then maybe the first charge, you can call it 2. And then the second charge, we are told that the sum of the 2 is 9. So if one is 2, another one is that. So this one, to get it, I take this one the other side, so that this 2 will be 9 minus q. So another one, and we can, since this is in the order microcoulombs, so we can also take there the micro value, so that we cater for it in the calculation. Then another one is 9 minus q, then exponent -6. Then we are dividing by the separation, which is 0.1 squared. And we are given that this force is 18. That force is 18. So we can say that 18 is 9 exponent 9, then q exponent -6, 9 minus q exponent -6, to 0.1 squared. Then you get your calculator, you handle this, handle that, and this, and the 18, so that we see where we head. So when I get my calculator, I will end up with 18 equals 0.9 q. 18 equals 0.9 q into 9 minus q. So how do I solve this? I can divide by 0.9 both sides. So when I divide by 0.9, this one will give me 20 equals, now this q, I open the bracket, will be 9q minus q times q will be q squared. You can see that we are getting a kind of a quadratic equation, so which I can arrange as q squared minus 9q plus 20 equals 0. And we know how we solve quadratic equation. I can use the general formula, where q will be 9 plus or minus the square root of minus 9 squared minus 4 times 1 times 20, then over 2 times 1, where 1 is our a. Remember the general formula. You can consult mathematics. So finally, we shall have q to give us two values. One will be 4, a positive, and another one will be 5, and it's also positive if you do that one. What does this mean? It is giving us our two values. So one is 4, another one is 5. Remember, this is q. So when you put there this one, to know what was here, then that is 4 exponent -6. So therefore, the charges are 4 exponent -6 coulombs and 5 exponent -6 coulombs. And ideally, when you add the two, you get this 9 that they are telling us. Or this one is just a combination of physics and mathematics. Simple ways to handle, and that is it. I know you just want to do something. You can write this. You just write, calculate the force of attraction. Calculate the force of attraction between charges of +5 microcoulombs. +5 microcoulombs and -3 microcoulombs pressed 80 centimeters apart in air. I repeat, calculate the force of attraction between point charges of +5 microcoulombs and -3 microcoulombs pressed 80 centimeters apart in air. When you get the answer, or when you have a question or any concern, just reach to us. We are called Back Science Education Consultants, and we provide a variety of education services, not limited to online teaching, Zoom lessons, guidance and counseling, and these lessons that we put on YouTube for your own consumption. Stay home, stay safe, stay blessed. You can subscribe to our YouTube channel, Back Science Education Consultants, and share so that you can help us minister to very many students there who may need a teacher, but of which the teacher is fearing to transmit COVID to them or fearing to contract COVID from them. But here we are, giving you science which has no COVID. Stay safe. Don't forget to subscribe.